By 1920, over 250,000 miles of railroad track cut across every road and town in America. People were dying at railroad crossings, and nobody could stop it. The best protection most crossings had was a wooden sign that read, "Look out for the locomotive." But in 1909, a man named Albert Hunt, who spent his days keeping the Pacific Electric Railway running across Southern California, watched a crossing watchman swing a red lantern back and forth in the dark. And he saw something no one else had seen. The answer, the magnetic flagman, had been in their hands the entire time. In 1905, getting killed by a train was one of the most ordinary ways to die in America. By the turn of the 20th century, the American railroad had conquered the continent. Track mileage had been climbing for 50 years straight, and by 1920, it peaked at over 250,000 miles. That is enough steel to wrap around the earth 10 times over. Every city, every farming town, every coal patch and lumber camp in the country was stitched together but by rail. But all that track had to go somewhere. It did not go around towns. It went straight through them. And every place where a road met the rails, you had a grade crossing. By the early 1900s, there were hundreds of thousands of grade crossings scattered across the United States. For most of the 19th century, that was not much of a problem. Horses moved slowly, wagons moved slowly. A driver sitting out in the open air could hear a steam whistle from a mile away and pull his team to a stop. The railroad crossings managed themselves. Then came the automobile. When Henry Ford put the Model T into production in 1908, he did not just change how Americans traveled, he changed how Americans died. Within a decade, millions of Ford automobiles were on the road. They were faster than horses, louder than horses, and starting around 1910, manufacturers began selling them with enclosed cabins, glass windows, and roofs that sealed the driver off from the outside world. That sealed cabin turned every railroad crossing in America into a trap. A driver in an enclosed Ford could not hear a train whistle over his own engine noise. He could not feel the vibration of the rails through a rubber tire the way a horseman could feel it through the ground. And at 20 or 30 miles per hour, by the time he saw the locomotive, it was already too late. The newspapers called them accidents. But they kept happening the same way. A farmer heading to market on a Saturday morning. A mother driving her children to church. They approached a railroad crossing they had crossed 100 times before, and this time a train was coming that they never heard and never saw. The old system had exactly one answer for this, and it was a man with a lantern. At the busiest crossings, railroads stationed watchmen who stood trackside and swung a red lantern in a wide arc whenever a train approached. That side-to-side sweep was the universal railroad signal for stop. Every railroader in the country knew it. Every motorist who had ever waited at a crossing had seen it. But a watchman cost money. He needed to be paid, he needed to sleep, and he needed to be replaced when he got sick or quit. You could not put a watchman at every crossing in America. There were too many crossings and not enough men. So at the crossings that could not afford a watchman, there was nothing. Just a wooden crossbuck sign nailed to a post and a prayer that the driver was paying attention. Fatalities. Well, at railroad crossings increased every year through the 1920s. The automobile had outrun the safety systems that were supposed to protect it, and nobody had a solution. Nobody except a mechanical engineer working for a streetcar company in Los Angeles. The Pacific Electric Railway was not a quiet little trolley line. By 1911, it was the largest interurban electric railway system in the world. Over 1,000 miles of track fanning out from downtown Los Angeles to Long Beach, Pasadena, San Bernardino, Santa Ana, and dozens of towns in between. They called the cars the red cars, and on a busy day, the Pacific Electric system ran over 2,000 trains, and nearly every one of those red car trains crossed public roads at grade level. No overpasses, no tunnels, just steel rails laid flat across the same streets where automobiles were now showing up by the thousands. The Pacific Electric had a crossing problem worse than almost any railroad in the country. Red cars shared urban streets with automobiles in downtown Los Angeles and ran through residential neighborhoods where children played near the tracks. The collisions were constant, and they were getting worse. Albert Hunt worked as a mechanical engineer at Pacific Electric. His job was keeping the system's equipment running, which meant he understood better than most people exactly where the failures were happening and why. He saw the accident reports. He knew which crossings were the worst. And he watched night after night as the company's crossing watchmen stood trackside doing the only thing they could do, swinging a red lantern in a slow, steady arc. That arc, that simple, ancient motion. It was the one warning that every person in America already understood. Railroaders had been using it for decades. A red lantern swung side to side meant stop. It required no training and no signs to read. You saw the motion and you knew. In 1909, Hunt asked the question that would change railroad safety forever. What if a machine could swing that lantern for you? The first prototypes were built right in Pacific Electric's own shops in Los Angeles. Gear-driven mechanisms replicated the watchman's arc, using a red metal disc instead of a lantern. They worked. Trains triggered them automatically through track circuits, and drivers could see the swinging red disc from a distance. But the gears wore out. The mechanisms jammed in bad weather. Maintenance crews were constantly pulling them apart and putting them back together, which defeated the whole purpose of replacing the human watchman with a machine. Hunt went back to the drawing board. What he came back with was the design that changed everything. Instead of gears, he used alternating electromagnets pulling against an iron armature. The red steel target disc, just under 2 feet in diameter, hung like a pendulum and swung back and forth between the magnets. A red light glowed in the center of the disc. With every swing, a mechanical gong rang out. It combined sight, motion, and sound in a single device, triggered automatically by the train itself, with no moving gears to wear out and no watchman to pay. The first magnetic flagman was installed at a busy crossing near Long Beach, California in 1914. Almost immediately, collisions at that crossing dropped. Pacific Electric had found its mechanical watchman. Now the rest of the country was about to find out about it. The Santa Fe Railroad was one of the first to come calling. After the Long Beach installation proved that an automatic signal could actually reduce collisions, Pacific Electric started putting the magnetic flagman at crossings across its entire network. Railroads from outside California started asking where they could get one. The Magnetic Signal Company operated out of a factory on East Slauson Avenue in Vernon, just south of downtown Los Angeles, with rail lines from the Union Pacific, Southern Pacific, and Santa Fe running right past its doors. Raw materials came in by rail. Finished signals shipped out by rail. The company eventually opened sales offices in New York, Chicago, St. Louis, Salt Lake City, Seattle, and Washington, D.C. 3 mechanically identical versions of the magnetic flagman came off the production line. The upper quadrant model mounted on top of a steel pole and waved the red disc above the motor box. It was built for tight spaces where there was not room to extend an arm over the road. A cast iron counterweight on the opposite side kept the swing balanced. The lower quadrant version was the one most people picture when they hear the word wigwag. The motor box sat on top, and the red disc hung below on a cantilever arm that extended out over the road. Drivers saw it swinging right above their windshield as they approached. You could not miss it, which was exactly the point. Then there was the rarest of the 3, a lower quadrant signal enclosed inside an octagonal steel frame that railroaders called the peach basket. The frame protected the mechanism from passing trucks, and the Union Pacific Railroad used most of them. In 1923, the American Railway Association made it official. The wigwag was adopted as a standard-grade crossing protection device. Over the next 2 decades, the Magnetic Signal Company would build and ship more than 7,000 units. 7,000 magnetic flagmen standing guard at railroad crossings from coast to coast. The Santa Fe ran them across the desert Southwest. The Norfolk and Western installed them through the Appalachian coal country. The Chicago and Northwestern put them at crossings across the Midwest. They appeared on Alaska's Copper River and Northwestern Railway, on sugarcane railroads in Hawaii, and at crossings in Canada and Mexico. And they did not stop at the border. Magnetic flagman signals showed up in Australia, New Zealand, and parts of Europe. A device built in a factory in Vernon, California, was now protecting railroad crossings on the other side of the world. But nowhere were the wigwag signals more at home than in Southern California, where the whole thing started. The swinging red disc and the steady clang of the gong became part of the landscape, as familiar to Los Angeles drivers as the red cars themselves. You grew up hearing that bell. You grew up watching that pendulum swing. It meant a train was coming, and you stopped. The magnetic flagman had become the mechanical watchman that Albert Hunt imagined in 1909. One machine doing the job of thousands of men at thousands of crossings every hour of every day. But nothing about the American railroad stays standard forever. If you're finding this story interesting, hit subscribe. I cover the forgotten machines and engineering behind America's railroads every week. Everything about the magnetic flagman started with a single piece of railroad track. It started with the track circuit. A section of rail near the crossing was electrically isolated from the rest of the line. When a train's steel wheels rolled onto that section, they completed the circuit between the 2 rails. That electrical connection triggered the signal, no human input required. The train announced itself. Inside the motor box sat 4 electromagnets arranged in pairs. When the circuit activated, current flowed to the first pair of magnets, pulling the iron armature and the attached red disc to one side. Then sliding contacts inside the mechanism switched the current to the opposite pair, pulling the armature back the other way. Back and forth, back and forth. The disc swung like a pendulum between the magnets, and each time it reached the end of its arc, a mechanical gong struck. A red light mounted in the center of the disc burned the entire time the signal was active. So a driver approaching that crossing got 3 warnings at once. The red light caught his eye. The swinging disc held his attention. And the gong made sure he heard it, even if he wasn't looking. Even if he missed one, the other 2 were still working on him. The Magnetic Signal Company offered a range of options to fit different conditions. Crossings in windy territory could be fitted with a round counterbalancing sail mounted opposite the disc to keep the swing steady. There was an adjustable turret mount for crossings where the cantilever arm could not extend fully over the road. And one of the smartest details was an out-of-order warning sign built into the mechanism that dropped into view automatically if the signal lost power. The magnetic flagman signals could be ordered in 3 different voltages. Most railroads used the standard 8-volt direct current configuration. Pacific Electric, which ran on streetcar power, used 600-volt direct current units. The Norfolk and Western, the Winston-Salem southbound, and the Milwaukee Road ran 110-volt alternating current models. Since alternating current did not generate the same torque, those alternating current units used all 4 magnets to get the disc swinging, then cut 2 of them off once full motion was reached, and let the remaining pair maintain the rhythm. When the train cleared the track circuit, the current stopped. The magnets went dead, and the disc, with nothing left to pull it, swung gently back to center and hung still at the railroad crossing. Silent, waiting for the next train. The thing that killed the wigwag was not failure, it was success. The magnetic flagman had proven beyond any doubt that automatic crossing protection saved lives. By the 1940s, the federal government wanted something even better. The Interstate Commerce Commission mandated that all new railroad crossing installations use alternating red lights with crossbucks, the system we still see at railroad crossings today. The wigwag could not meet the new standards. Its electromagnets drew more power than the newer flasher systems. It had moving parts that wore down over time, and the regulations now required a kind of fail-safe visibility that the swinging disc, for all its charm, could not guarantee in every condition. After 1949, no new wigwag could be installed at any railroad crossing in the United States. The Magnetic Signal Company was sold to the Griswold Signal Company of Minneapolis shortly after World War II. The factory on East Slauson Avenue kept building signals until 1949 and replacement parts until 1960. Then the production line went quiet. But the wigwag didn't vanish overnight. Grandfathering laws allowed every existing signal to remain in service until the crossing it protected was upgraded, and upgrades cost money. At rural railroad crossings on branch lines where train traffic was light and budgets were thin, nobody was in a hurry to replace a signal that still worked. So the wigwags held on through the 1960s, through the 1970s, through the 1980s. In 1983, federal data showed 2,618 crossings in the United States still equipped with wigwag signals. By 2004, that number had dropped to 1,098. The count kept falling. Every time a crossing was modernized, another magnetic flagman came down off its pole. One by one, the signals that had protected those railroad crossings for 40, 50, 60 years were unbolted and hauled away. Some went to scrap yards. Some ended up in barns and garages. A few found their way to railroad museums. And as the spare parts dried up, even the ones that were still standing became harder and harder to keep running. The paired wigwags at Baraboo, Wisconsin, former Chicago and Northwestern signals that had been swinging since the 1920s, were taken down and delivered to the Mid-Continent Railway Historical Society. The last mainline magnetic flagman in the country, an upper quadrant signal at Delhi, Colorado, on the BNSF Railway, was removed on March 9, 2021. Once, they had been everywhere. 7,000 signals at crossings across the country and around the world. Now, the magnetic flagman was down to 14 active signals, all of them in California, all of them on borrowed time. And the gong that had warned a century of American drivers was going silent, one crossing at a time. Every railroad crossing in America today uses the same basic idea. A warning device triggered automatically by the train itself that tells a driver to stop. Red lights, bells, and gates that lower across the road. The technology has changed. The principle has not. And if you look closely at the yellow crossbuck sign that hangs at every one of those crossings, you will see something familiar. A black cross on a yellow background, rotated 45 degrees into an X. That crossbuck symbol was standardized during the wigwag era. The Santa Fe Railroad liked it so much, they built it into their corporate logo. It is still there at every railroad crossing in the country, more than a century after Albert Hunt watched a man swing a lantern in the dark. And there is one more thing, something you can still see out on the railroad today. When a worker needs to tell an engineer to stop a train, he does not wave his arms overhead. He does not hold up a hand. He swings his arm in a slow side-to-side arc, the same motion that crossing watchmen used in 1905, the same motion that Albert Hunt built into a machine in 1909. Rule 5.3.1 of the General Code of Operating Rules, still on the books today. The magnetic flagman is gone from the American railroad crossing. The last 14 signals in California are hanging on, but the spare parts are running out, and the crossings will be upgraded eventually. The machine that Albert Hunt invented will disappear from active service within our lifetimes. But the motion endures. The arc of a red lantern swung side to side in the dark still means stop on the American railroad. It meant stop when the watchman did it by hand. It meant stop when the magnetic flagman did it with electromagnets. And it means stop today, out on the main line, when a worker swings his arm and a locomotive grinds to a halt. One man saw that motion and understood what it was worth. And for over a century, it saved lives. If you want to see how another piece of forgotten American engineering changed the railroads forever, that video is on screen now.